Considering a 2000 amp load with 200 feet to 500 MCM feeders, let's analyze the price difference between using aluminum and copper wiring. Assuming a price of 25 cents per pound for copper and 19 cents per pound for aluminum, the price difference for 2,500 pounds of aluminum in place of copper would be $576. While this may seem like a significant initial saving, it's crucial to consider other factors beyond the raw material cost. Many prefer to work with copper due to several advantages. Firstly, copper offers an increased bending radius. This reduces the potential for strain hardening and future problems with wire breakage. A tighter bending radius with aluminum can lead to the material becoming brittle over time, increasing the risk of failure. Secondly, copper has an increased current carrying capacity. This allows for upsizing of the wire by one size smaller than aluminum. To carry the same current, aluminum conductors typically need to be larger than their copper counterparts, potentially negating some of the initial cost savings due to the need for larger conduits and termination hardware. Thirdly, copper provides increased mechanical strength, which reduces the potential for wire damage during installation. Copper is less prone to damage during pulling and handling compared to aluminum. Fourthly, there is a reduced likelihood of problems with loose connections due to the resilience of copper. Copper maintains its contact pressure better than aluminum, minimizing the risk of loose connections and subsequent overheating. Fifthly, reduced labor costs are often associated with copper due to its easier bending. The increased flexibility of copper simplifies installation and reduces the time required for bending and terminating conductors. Sixthly, copper poses a reduced risk of broken strands when pulling the wire into the conduit. Copper's higher tensile strength makes it less susceptible to strand breakage during installation. In general, aluminum wire is a cost-effective alternative to copper wire when the distance is long and the upsizing of the wire is minimal. In scenarios with long distances, the weight savings of aluminum can become significant, offsetting the need for larger conductors. When the upsizing of the wire is significant, then the cost benefits of using aluminum wire can be minimal. If substantial upsizing is required to meet capacity requirements, the increased material cost, conduit size, and termination hardware can negate the initial cost savings. To summarize the key considerations when choosing between aluminum and copper for a 2000 amp load with 200 foot 500 MCM feeders, firstly, weigh the initial cost savings of aluminum against the potential increase in material costs due to upsizing. Secondly, evaluate the impact of bending radius requirements on long-term reliability. Thirdly, consider the labor costs associated with bending and terminating both aluminum and copper conductors. Fourthly, assess the importance of long-term connection reliability and the potential for loose connections with aluminum. Fifthly, factor in the increased mechanical strength of copper and its resistance to damage during installation. Sixthly, take into account the potential for voltage drop and hot spots with aluminum connections, which might require more frequent maintenance. In conclusion, the decision between aluminum and copper wiring involves a multifaceted analysis that considers cost, performance, and long-term reliability. While aluminum may offer initial cost savings, the increased current capacity, mechanical strength, and ease of installation of copper often make it a more favorable choice, especially when upsizing requirements are significant.